Okay, so how can you find acceleration, retardation, and distance covered under a velocity time graph? I'm going to show the easiest way. Step one, you just have to know some of the equations of motion. Then you are okay. And the equation of shapes. Simple as that when you find in the area under the graph. Now, find the acceleration. First, before you answer any question, you have to start the graph. There is this velocity here and there's time here in seconds. Velocity has been given in meters per second. You have velocity here at 15, 0, time also 0, 5, 8, 10. They want you to find the acceleration in the first 5 seconds. So how do you find the acceleration? So, to find the acceleration, you need to know that acceleration is equal to change in velocity, which is final minus initial over time taken. Now let's get our data. Okay. Let's get our data. Our v is the final velocity there, 15 meters per second. Our u is the initial velocity here, is 0. Our time is a change in time between 5 and 0 to just 5 seconds. So you can now replace. That will be 15 meters per second minus 0 meters per second over 5 seconds minus 0 second, the change in time, right? And this will give us 15 meters per second over 5 seconds, and this will give us an acceleration of 3 meters per second squared. You're done. Then B says find the distance. Now the distance covered is everything here. It's just the area under the what? Under the curve. So how do you answer that one? Distance under the curve, this is what first you have to identify the shape being formed. This shape being formed here is what we call a trapezium. Now a trapezium, you need to use the formula how to find the area of the trapezium in order to find the area under the graph. Now a trapezium is branched into 3 parts. The first part is this part from there, and the second part is from there to there. The third part is the height. Now the height from there is the same as from there to there, so the height here is 15. Then from 0 to 10 is just 10. We call it B. So B here equal to 10. A is between 5 and 8. So 8 minus 5, that will give us 3. Now distance, since it's a trapezium, we're going to use this formula. Half A plus B times H. That is the formula that you use. So this will be, proceed. So this will be half A is 3 plus B is 10, height is 15. So from here, so this is physics. Even paper 1 they can bring, it's the same procedure. So we have half 3 plus 10 is 13 times what? Times 15. So 13 times 15 divided by 2, and the distance is giving me 97.5 meters. That's the distance. And the last part talks about the retardation. How do you find the retardation? Now the retardation is what you find in this part here. In this only part here, where the graph is decreasing, that's where you find the retardation. Now the retardation is just the opposite of acceleration. So we are going to say retardation is equal to V minus U over T. Same formula, so long as I put it there. So the change in time is between this point and that point. So we're just talking about that region here. So that is 10 minus 8. So the time is 2. The initial velocity here is 15 and the final is 0. So we're going to say 15 minus 0 over 2. So this will give us 15 over 2. To give us 7, 1 over 2 meters per second squared. and we put the final answer as retardation is equal to 7.5 meters per second squared, or you can say acceleration is equal to negative 7.5 meters per second squared. That is your answer.